Hello again, and welcome once more to a video introduction and illustration of IBM's WebSphere Application Server for z/OS Optimized Local Adapters, or Wola for short. In this section, we'll cover how Wola operates with CICS. For Wola and CICS, we will discuss issues of security assertion and transaction assertion. To best understand how the Wola support operates in CICS, it is important to remind ourselves of the concepts of inbound and outbound calls. The key is which side initiates the conversation after registration is complete. We start with a WebSphere application server address space and an external address space, which in this section will be CICS. In the WAS server, there is a Java program which will use Wola, and in the CICS region, there will be a native language program that will use Wola. Both sides have the respective Wola support elements installed and enabled. In a few moments, we'll see what those consist of for CICS. The act of registration is always initiated by the external address space into the WAS server. Once registration is complete, then one side or the other will begin the conversation. For outbound, the Java program in WAS will begin the conversation. It will form up a message and send it over Wola to the program in the external address space. The program outside of WAS receives the message and responds. For inbound, the reverse applies. The program in the external address space will form up a message and send it over Wola to the Java program in WAS. The Java program receives the message and responds. Let's now review how Wola operates in CICS for outbound support. There are four elements to consider. Imagine an application server and a CICS region. The low-level Wola implementation in CICS is provided with a supplied task-related user exit, or TRU for short. A supplied link server task is what handles the Wola call from the program in WAS and prepares to invoke the named CICS program. In the Java Programming Considerations section, we'll see how the CICS program is named in the Java program. A supplied link invocation task is what performs the direct program link to the named CICS program. In addition, there is a control transaction called BBOC that provides a handy way to start the TRU and the link server task. Did you notice we did not mention the Wola native APIs at all? The link server task and the invocation task shield your CICS program from having any awareness of Wola. Provided your CICS program is capable of being invoked with a direct program link using either COM area or channels and containers, then your CICS program remains unchanged. BBOC is a 3270 screen transaction supplied with Wola. We will review the BBOC commands here because it illustrates an important point about when registration takes place. Again, imagine a WAS server and a CICS region. Once installed into the CICS region, the BBOC transaction is accessed using a 3270 terminal session logged into the CICS region. The command syntax for BBOC is spelled out in detail in the Product Info Center. Search on the string rdat_CICS to go directly to that article. The first command we will look at is BBOC start true. As the name implies, this will start the Wola task-related user exit in the CICS region. It is also possible to use a supplied program list table post initialization program to start the TRU when the CICS region starts. Two such PLTPI programs are supplied. The one to start the TRU is called BBO-ACPLT. Notice how starting the TRU does not itself cause registration to take place. Another command is BBOC register. This will cause registration to take place. Registration requires the cell, node, and server short name to be specified. The final command we'll look at is BBOC start server. This starts the link server task. This command will also result in a registration into WAS. So if you intend to use BBOC start server, then you don't need to use BBOC register. Finally, a second PLTPI program is supplied that will allow you to issue BBOC commands at CICS startup. The program name is BBO-ACPL2. You may pass in a string of commands up to the limit imposed by CICS of 60 characters. Let's turn our attention to how the propagation of security context may be accomplished when going outbound from WAS into CICS. Two approaches are possible. Once again, we start with the WAS server and the CICS region. The first approach involves asserting the user ID on the WebSphere thread into CICS. The true is started along with the link server task, and a registration into WAS is performed. The link server task itself will have an ID associated with it. This is defined in CICS. Notice the security equals yes parameter for the start of the link server task. A logged-in WebSphere user named John performs an action that results in a call across Wola into CICS. John's identity is propagated across Wola into CICS and up to the link server task. The link server task then starts a link invocation task under the passed-in ID of John. CICS will check SAF to make sure the ID of John is valid. The link invocation task then performs a direct program link to the named CICS program. The ID of John is used to run the named CICS program. Notice how the link invocation task goes away. Eventually, the called program completes. Now imagine we have more users in WebSphere. They too perform an action that results in a call across Wola into CICS. Their identities are propagated into CICS just like John's was. And just like with John, a link invocation task is started, one for each identity asserted into CICS. CICS performs a check against SAF for each of the identities, just as it did with John. The individual invocation tasks perform a direct program link of the named CICS program. The individual IDs are used. An alternative approach is to specify security equals no on the link server task, along with reuse equals yes. Again, the link server task is started with the identity defined to it in CICS. But note what happens next. An invocation task is started with the user ID of the link server task. Calls start coming across Wola. Because security equals no was specified, there is no attempt to assert the WebSphere thread identity into CICS. The link server task ID is used for every call. Further, only one copy of the invocation task is active, and it stays up. This is because reuse equals yes was specified on the link server start command. The calls result in the DPL of the named programs. But only one ID is used, the ID defined to the started link server task. We have just illustrated a trade-off. Which you use is a matter of your requirements. The first approach we illustrated provided for security granularity, but with the overhead of repeated starts and stops of the invocation task, along with repeated checks against SAF for the asserted IDs. Based on your requirements, you may need to have that security granularity. The slight overhead of the invocation tasks is acceptable. On the other hand, you may decide that such granularity is not really needed. You would rather have as much throughput as possible. The use of a single ID to invoke the named programs is acceptable. In that case, security equals no with reuse equals yes may be your preferred approach. You are not required to use the link server task. It is possible to bypass it entirely to get even more performance out of Wola. So, we remove the link server task and the invocation task from our picture. The true is always needed, so that stays. The BBOC control transaction is not required, but you may wish to use it. In any event, BBOC is not involved when calls are coming across Wola. If you bypass the use of the link server task, it means that you must make use of the Wola native APIs in your custom program. We'll explore those APIs in a later section of this series. Further, the APIs you use will be the ones to host a service. That means they will ready the CICS program to listen for a call from WAS. Registration into WAS is needed as always. How that registration is performed is up to you. You may do that with the BBOC register command, or you may use the BBO A1reg API from your program. The Java program in WebSphere prepares to call across Wola to your CICS program. We'll explore the programming requirements for the Java program in a later section of this series. The Java program calls into CICS across the established registration. Your CICS program, using the Wola host-to-service APIs, receives the call. It then invokes your custom DPL function to invoke the named CICS program. The link server task function is provided with Wola because it provides considerable ease of use, and it completely shields you and your programs from coding to the Wola native APIs. The link server task function is a very good performer. But like anything where simplicity of use is involved, there is a degree of overhead associated with providing that ease of use. What bypassing the link server task provides you is the ability to streamline your function as much as possible. You lose the ability to assert security and transaction into CICS. But that may be acceptable based on your requirements. If so, then you can extract even more performance from Wola. Let's take a quick look at the inbound scenario. Here, the CICS program calls into WAS over Wola. We have a CICS region and a WAS server. The true is present, but the link server task is out of the picture. An EJB is present in the WAS server and will serve as the target of the Wola call from CICS. A CICS program is present in the CICS region and will perform the calls into WAS. Registration is required as always. This may be accomplished using the BBOC register command or the BBO A1reg API from the CICS program. The CICS program makes use of the Wola inbound APIs to call the target EJB in WebSphere. This implies modifying existing CICS programs to use Wola. That may not be acceptable to you. An alternative is to write a small bridge program that implements the Wola APIs. Your existing CICS programs simply DPL the custom bridge program. Your existing CICS programs remain unchanged. The custom bridge program becomes a kind of Wola service to programs in the CICS region. Let's summarize what we have just discussed. We'll organize this by outbound first, then inbound. For outbound calls and security, you may assert the ID of the WAS thread into the CICS region if you use the link server task and specify security equals yes. Or you may choose to use the identity of the link server task by specifying security equals no. Or you may bypass the link server task entirely. If so, then no identity is asserted and the ID defined to your program in CICS is used. If you specify transaction equals no, then no transaction started in WAS is propagated into CICS. If you specify transaction equals yes, and you're at a level of WebSphere application server between 7004 and 70011, then you are limited to sync on return only. That restriction is relieved starting with 70012. With WAS 70012 and above, you have the ability to have CICS participate in global transactions started in WAS with two-phase commit support. This requires you have CICS Transaction Server 4.1 or higher. If you choose to bypass the link server task, then no transactional propagation is supported. For inbound and security, the identity of the CICS region or the CICS application ID may be asserted into WAS. The cbind class is what protects WAS from unauthorized calls. And for transaction, WAS may participate in a global transaction started by CICS with two-phase commit support. This has been available since Wola was first released with the 7004 maintenance.